going through the flow control and all, right? So today we'll talk about object-oriented programming. Okay. So as a Java developer, you have to be very thorough with the object-oriented programming. As a Java developer, you have to be thorough with object-oriented programming. So this is building blocks for you people. If you want to work with Java, yes, throughout Java, you'll find that you'll be using this object-oriented programming. Yeah. So, can someone explain this object-oriented programming? Yes. What do you people think? What is this object-oriented programming? Interacting with object. Okay. So whatever you can explain, whatever you know about object-oriented programming, tell me. Okay. Yes. Whatever you know about object-oriented programming, please tell me. Okay. Which gives flexibility and extensibility. Okay. And what else? Creating objects and using them to interact. Okay. Superclass which is derived from subclass. Okay. Okay. Fine. Good. So whatever you know about object-oriented programming, okay, you're explaining. So, okay, we use objects rather than logic data. Okay. These are all the answers which I got. So let me explain it from my side. Okay. So object-oriented programming, I can say that it is all about applying object-oriented concepts in the programming. I can say that object-oriented programming is applying object-oriented concepts in the programming. I can say that this is object-oriented programming is a programming methodology. Programming methodology. Okay, that means an approach which is followed in the programming. This is one of the approach which is followed in the programming. Object-oriented programming is a methodology, I can say. It is one of the methodologies. Yes. Yeah, just a second. Oh, give me 1 minute, please. I'm sorry. Just a minute. Yeah, I'm sorry. So object-oriented programming is a programming methodology, I can say. So in object-oriented programming, we apply or we use object-oriented concepts. So I can just do this. I'll just combine these two statements. When I ask you people to make a note of it, you can do that, okay? Yeah. So object-oriented programming is a programming methodology where we use or apply object-oriented concepts in the programming. Yes. Yeah, please make a note of it. So first of all, now we need to understand what are object-oriented concepts. I'm saying that in the programming, we apply object-oriented concepts. So in the programming, I'm saying that we apply object-oriented concepts. Yes. So what are object-oriented concepts? First, you need to know that. First of all, let me give you the importance of object-oriented concepts. Let me tell you people the importance of object-oriented concepts. So these are just concepts. I'm not talking about programming here. Okay. So their object-oriented features. Okay. So that concepts includes that object-oriented features. So yes, what you said, we'll see. Okay. They are object-oriented features. Yes. So object-oriented concepts, you'll find that we use them in the programming. The applications, I'm talking about applications of object-oriented concepts. And they are also used in analysis or design and analysis, we say. Design and analysis. Yes. These are the two different areas in the software engineering where we use object-oriented concepts. Yeah. So here, design and analysis is also very important. Design and analysis is also very important, I can say. Yes. Because you see, before we develop an application, yes, first of all, you'll find that we'll create a design for that application. The way you have a plan for the building, the way you got a plan for the building. Similarly, for the application also, you'll have a plan. Okay, for the application also, you'll have a plan or design, I can say. We call it as a design. Before an application is developed, first of all, a design will be created for that application, which describes the complete application, the components, the modules, whatever it is. Complete details about that application will be you know, will have in that design. Yes, and it is also based on object-oriented concepts. Later on, the design will be implemented through coding. Okay. Yes. Fine. So these are the two important areas in which the object-oriented concepts are used. So programming means, you know, there are many programming languages like Java, C++, C Sharp, PHP, Python. They are all object-oriented programming languages. Design and analysis, it is basically done here. There is a popular modeling language which is used for designing the systems, software applications or software systems. What is it? Can you people tell me? Yes, UML, Unified Modeling Language. Unified Modeling Language. So for both the object-oriented programming and the design, see, which is based on object-oriented concepts, you will find that, yeah, for both UML and programming language, they both are based on object-oriented concepts itself. Okay, so UML is used for designing the software systems or applications, I can say. And one important thing, let me tell you people, as a developer, as a Java developer, you are expected to have at least a knowledge of minimum knowledge of UML. So if whenever you get some time, please go through UML. Okay. Yes. So now you understood the importance of object-oriented concepts. You understood the importance of object-oriented concepts. Now, what are these object-oriented concepts that you need to know? I've just explained the importance of object-oriented concepts. Okay. So now let's try to understand what are these concepts. You know, actually, it's not rocket science or something like that. It's very simple, dead easy. And you people are very much aware of it, I can say. You people are very much aware of this object oriented concepts, I can say. Okay, so object oriented concepts, you'll find that yes, object oriented concepts are derived from the real world. You know that object oriented concepts are derived from the real world. I can say that each and everything which we see in the real world is an object. Or in other words, I can say that anything in this world, in the real world, is an object. Anything in this world is an object. Okay, you can make a note of it this way also. Object is anything in the real world. Object is anything in the real world. I can say that object plays, or I can say that object is an important actor. Object is an important actor in the object oriented concepts. You see, the name itself, it suggests the object oriented concepts. You'll find that okay. So you see, the name itself is suggest object oriented. That means everything is based on the objects. So that name itself, it emphasizes a lot on object, right? So as an object oriented programmer, so you need to know what is an object. As I told you people, object is anything in this world. Okay, yes. And object, you know what, object has got characteristics. Object has got two characteristics, I can say. What are they? Properties and behaviors. So please don't mind. Today we'll talk about a theory lot, okay, instead of programming, because so you need to understand the roots of object oriented programming. That is what we are trying to do, okay? So that once you know the roots of object oriented programming, it won't be that difficult for you people to in work with object oriented programming. Okay, apply the object oriented concepts. As I told you people, object oriented programming is all about applying object oriented concepts in the programming. So what are these object oriented concepts? First, let's try to understand this. Programming, forget about it, don't worry. Okay, I mean, for this class, okay, don't worry about programming. So definitely you'll see it. Okay, so first of all, let's try to understand uh, the basics, the origins of from where these concepts have been derived, how these concepts look like, and then we'll try to implement them. The second stage will be applying these concepts in the programming. Okay. Yes. So object has got two properties, oh sorry, two characteristics. What are they? Properties, I can say that properties of an object, you can say that they describe an object. Properties describes an object. Properties basically describes an object. Behaviors define defines behaviors define actions performed by an or on an object, I can say. Behaviors define actions performed by an object or on an object, I can say. Yes. Okay. So we'll try to understand this characteristics of an object with the help of an example. Okay. So let's say I said anything in this world is an object. So a person, some XYZ person is also an object. If I say person is an object, that means for the person will have properties and behaviors. So what are the properties of a person object? Person has got name, person has got age, person has got color, height, right? So gender, these are the various properties of a person which describes a person. That is what I said. Properties describes an object. Properties basically they describe an object. What about behaviors? Behaviors, I can say that they define the actions performed by an object or on an object. So what are the actions? Okay, what are the behaviors here? What do people think? Yes, person can eat, person can walk, person can think, person can talk, right? So these are the actions performed by the person object. So hope you people got it. So this way you see an object will have properties and behaviors. So next, let's take another example. Let's say a savings account object. Let's take the savings account object. So if we talk about a savings account object, yes, you will find that we got, again, savings account is an object. You see, I'm talking about a bank account. Okay, in the bank you'll have savings accounts, right? So I'm talking about that account. So in that case, see what happens here for that account. Uh, Sorry, what are the properties of that account object? What do you people think? Yes. Okay. So so savings account will have an account number, right? Balance. These are the properties. Mm, Account status, whether it is open, closed, dormant, whatever it is, and you'll have validity. Okay. Um let's say branch. You have many properties. Yes, of course, I do agree with them. Yeah, I'm sorry. Fine. Pin. So you can consider several properties. Okay. Yes. Okay. Next, if we talk about the behaviors of the savings account object, what do people think? Yes. So we'll have deposit, withdraw, transfer of funds, you know, and actions, uh, transfer of funds, inquiry, balance inquiry. So these are the sorry, these are the various actions which you perform. Okay, yes, this way every object will have properties and behaviors that I want you people to understand. So that is the first thing in the object oriented concepts. Okay, yes. So when we talk about object oriented concepts, we have to start with the object because everything is based on object. Object is an important actor in the object oriented concepts. Object is a important actor in the object oriented concepts. Okay, okay. Next, you know, we have to talk about object oriented features. Okay, what are the features of an object? I can say that objects have features. So basically, we call them as object oriented features. Now you can say, what are the features? Inheritance, polymorphism, I also add this associations. Generally people don't talk about it, but I'll add it. I'll dare to do this. So associations, and we have abstraction, and what else? Encapsulation, right? So these are the object oriented features. That means these are the features which we'll see which are common in the objects. So inheritance. So when we talk about inheritance, when we talk about inheritance, inheritance is one of the object features or object oriented feature, I can say. Inheritance, I can say that it represents a relationship or a parent-child relationship between the objects. Inheritance, it represents a parent-child relationship between the objects. So when we talk about inheritance, you'll find that child object inherits, or I can say derives, or sorry, inherits the properties and behaviors of a parent object, I can say. Child object inherits the properties and behaviors of a parent object. So this is the most common relationship which we see in the objects. You know, I'm talking about the objects in the real world. Okay. Now whatever you see around you, all are objects. Am I right? So each and everything which you see around you, whatever you see around you, all are objects. Whatever you see around us, you see, as of now, you might have a laptop in front of you people. It is an object. A pen, a book, mic, phone, everything, including us, even we are objects. You see, inheritance is also one of the common features which we see in the objects. You see, we are big examples for that, right? So, you know what? Now, whatever I am talking about, object properties, behaviors, inheritance, that is features, each and everything will be implementing in the programming, and we'll see what kind of advantages we have. Okay, yes. Later on, when we talk about the programming, when we apply this concept in the programming, you'll come to know about the advantages. Okay, yes. First, let's try to understand. We'll try to have a big picture of object-oriented concepts. You see, we are trying to just understand the facts or just uh, realize this world in terms of objects. We can think about it, right? Yes. So they're just facts which we need to once recollect. That's it. Okay. Next, you have polymorphism. Polymorphism. I want you people to change your thought process. Just try to see the world in terms of objects or object-oriented concepts. Okay. Yeah. So that will help you people to easily understand as well as apply them in the programming later on. Okay. Yes. Polymorphism. So, what is polymorphism? Polymorphism means, general meaning is many forms. It's a combination of two terms. Polymorphism means many forms. Okay, polymorphism means many forms, I can say. Okay, you see, now you'll find that here this is one of the most common features which you'll see in the objects again, polymorphism. Okay, so can someone explain this polymorphism? See, we are living in this world, right, since long time. So just think about it. So polymorphism. Okay. Same name, different behavior. Okay. Yes, you see, that's right. So object existing in more than one form. Polymorphism means, in simple terms, I can say that an object existing in more than one form. So example, water. So when we talk about water, you will find that Water is also an object and it exists in many different forms, I can say. Okay. How can I say that object has got this polymorphic behavior? It exists in more than one form. You see, water, I can say that, or it can change its forms. Same object can exist in different forms. Water. You see, if it is in liquid state, okay, you know, shapes, or you can say, you see, when we talk about mass, you see, if we freeze the water, if you freeze it, it becomes ice. Solid state of water is ice. If you heat it, it becomes vapors, gas state. You know, in liquid state, it is water. So the same water can exist in more than one form, right? An object, you see, water can change its forms, can change its forms here, right? Yes. Yep, that's right. So, you know what? It is not just confined to water, but there are many such objects. Even we see lot of many such objects in our day-to-day life also. Even we people, including us, Sagar, as Sagar said. You see, even a person plays many different roles. A person can be a father or a mother. A person can be a brother or a sister. A person can be a son or a daughter. A person can be a doctor, right? The same person can be father or mother. Same person can be sister, brother. That means I'm just taking both the examples. Otherwise, you'll say I'm biased towards one gender. Okay. So, you see, you take your example itself, or like, let's take my example. Okay. So, to my parents, I'm a son. Uh, so, I've got kids. For my kids, I'm a father. So, for my friends, okay, I'm a friend. For my siblings, I'm a brother. You see, in my office, okay, I'm a team member. I got a role. Okay, for you people, I'm a faculty. So I've got different roles to play. And you see, from role to role, so the behavior is going to change, right? So the way I behave, the responsibilities which I got, will change. They won't be same. Yeah. Just a minute, please. Just a minute. Yeah, I'm sorry. Sorry. So yeah, you see, a person, as I we took my example, right? the same person, myself, I'm existing. I play different roles. I got different responsibilities. So from context to context, my roles and responsibilities will be different. You see, from context to context, the way I behave, okay, the responsibilities which I got will be different, right? The way I behave with my parents will be different. The way I behave with my children, the way I behave with my siblings will be different from the way I behave with my colleagues in the office. So I got a role. You say accordingly my behavior also changes, but still I'm the same person, right? So I'm the same person. Yeah. So hope this is clear for you people. So this is one more feature which we'll see in the objects. This is another feature which we'll see in the objects. Yeah. Okay. Next, we got associations. I can say when I talk about associations, they can be different types. Like simple associations, a formal association. I can say. For example, now, when we talk about the association between you people and me, a faculty and a student association, it's a very simple association, I can say. Okay, it's a very simple association. Yes. Yes. It's a very simple association. Fine. Um, but associations can be uh, different types. Like you'll find that we have composition, aggregation. Okay, they are the other types of associations, I can say. It's just a second. Yeah, I'm sorry. So you have you have composition aggregation. So composition means I can say that an object which is made up of several other objects. An object is part of another object, I can say that is composition. Object An object is part of another object, or in an object you can have several other objects, I can say. So can you people give me an example for that?
This
Yes, object, it is part of another object. Yes, water in a bottle. That's right. uh, yes, there are many such examples here which you can consider. car engine. You see, car is sorry, engine is part of a car. Engine is actually part of a car. Okay. So this is another example. College department or department. You see, department is part of a college, right? College and a class. Employee, uh, you can say employer is not part of employee or something like that, but you can say a department and employee. Department, employee. So employee part is part of a department, right? Employee belongs to a department. Yes. Okay. Yes. That's right. Exactly. So RAM and your CPU or a computer and the CPU. See your phone and your SIM card, phone and SIM card, phone and your touchpad. So this way you can consider many such examples. So object is made up of several other objects, I can say. So an object is made up of several other objects. Yes. Fine. So aggregation is also a special case of composition, but I'll talk about it later. Okay. Next, you see, these are all the things which we see in the objects, right? You see, I'm talking about the real world objects, the most common objects which we see in the real world, right? Yes. You know what? Maybe sometimes it may look very silly, but yes, we use all these concepts in the programming. So whatever we are talking about, each and every bit, each and everything, whatever we are discussing now, it will be used in the programming. As a Java developer, you have to implement all these concepts in the programming. Yes. So as a Java developer, you have to implement all these concepts in the programming here. Yes. Fine. So next, what else we have? What are the other features? We have abstraction. Abstraction. So can you people talk about abstraction, how it is related to real world? So what is abstraction? Yes. What is abstraction? Okay, hiding features. So the concept of abstraction is all about hiding the irrelevant details or concealing the irrelevant details and only revealing relevant details. So that is abstraction. Abstraction is all about concealing irrelevant details. I'm only revealing relevant details here. Yes. Yes, that's right. Exactly. You know what? I can say that this complete world itself, it is based on the concept of abstraction itself. So each and every object which we talk about, each and every object I can say that which you see in this real world, it is based on abstraction concept itself. So without abstraction concept, okay, we cannot think about this real world. We cannot really think of this real world without abstraction concept. Abstraction is all over the place. Each and every object, it is actually built on the concept of abstraction itself. Fine. So for example, you see car and a buyer. So buyer who's interested in buying the car, they don't need to really know how exactly the car works, the mechanism, the complex mechanism which drives the car. They really don't need to know that, right? So, for example, here we can also, I can also say this. Let's say you bought a new car, okay, or suppose you got a car. Now, in order to drive that car, you don't need to understand how that engine works, right? How that complex mechanism which drives the car, that is engine, how it works. We don't need to really know that. We don't have to be a mechanical engineer. We really don't need to be a mechanical engineer to drive the car. Okay? Yes. So you see, we can control that complex mechanism. We can control that complex mechanism which drives the car through simple components like you see we have this steering, a wheel, we say gears, accelerator and brake, right? Clutch, brake, accelerator, that's it. So we have a very simple mechanism which helps us to control this complex mechanism again. So if you know how to control the wheel, how to switch the gears, how to control, how to accelerate, how to speed your car, how to control the speed of that car, that's it. That's enough. Yes, you can drive the car. You don't need to be a mechanical engineer, right? You don't need to do mechanical engineering for that. Yeah. So that is that simple mechanism. You see, it is hiding that complex mechanism here, so that you know that wheel I can say, and what else? The gears, accelerator, brake. So these are very simple mechanisms which help us to see hide that complex mechanism which drives the car. So hope you people got it. Yes, we'll talk about it. Okay. So as I told you people, I'm not talking about any programming. So first of all, will just concentrate on the concepts. Okay. Later on, we'll see how to apply those concepts in the programming. The application of object-oriented concepts. We'll discuss about it. Yes. Okay. Next, That is about abstraction. Okay, I'll give you the definitions also later on, don't worry. So next, I'm just giving you people a very high level overview of this. Abstraction is all about concealing the irrelevant details and revealing relevant details. Yeah, fine. So next, we got encapsulation, but I'll talk about it in the programming itself directly. So you see, these are the various features of an object, or we say object-oriented features. So which you will find in the objects. You see, in the object-oriented concepts, you see, did we deviate from an object? Did you find any deviation from the objects? Are we talking about anything other than object here? No, right? Each and every concept, whatever we have discussed so far, it's completely based on objects itself. You see, that's the reason why these concepts are called as object-oriented concepts. In the object-oriented concepts, we only study about objects. So, encapsulation, yes, we'll talk about it. Okay, yes. So I'll discuss about it later on. Definitely. In the programming itself, directly we'll see that. Okay. So now, what I want you people to realize is that here, you see, this complete world is based on this concepts, object-oriented concepts. Okay. Yes. So you see, this object-oriented concepts. Yes, you'll find that they exist independently. They are related to this real world, and its objects. The world is based on these objects. Yeah. Now we will be using these concepts in the programming. We'll be using these concepts in the programming. So we say object oriented concepts. So here, okay, there is a question. So can you please give me one example in which all these concepts comes together? You know what? I'm giving examples for each and everything here. Now, in general, you see, this real world itself is an example I'm saying. Everything comes up together here that you need to understand. That is what try to realize, think. I want you people to change your thought process. That is what you're not doing. So don't still be in this concepts. Come out of this concepts. Think about it around you. Everything is based on this. Okay? Yes. Try to realize it. So whatever you see around you, they're all based on this concepts itself now. Got it? Yeah. And I'm talking about these concepts now. I'm not talking about programming. Don't worry about programming now. That's not no, that's not my concern now. And it should not be your concern also. Okay. Yes. Next we'll see how to implement these concepts. That is the next thing. Yeah. Okay. Fine. So here now the question is, how do we implement these concepts in the programming? You see, there are programming languages which support these concepts. That means they provide the support such constructs which we can use to apply these concepts. There are programming languages like Java. So Java is one such programming language which provides the constructs, okay, which we can make use of to implement this object oriented concepts. So it supports these concepts. We can use these concepts to we can use these concepts in the programming, and we can build applications based on these concepts. Yeah. So such programming languages which support this object oriented concepts, which will allow us to implement this object oriented concepts, I can say that basically they are object oriented programming languages. They are actually object oriented programming languages. Okay. So most of you people, they might be wondering. So if you people have gone through this object-oriented concepts, okay, you might be wondering. Actually, I'm not talking about a class anywhere here. So how is class related to this object-oriented programming? What do you people think? So how is class related to these concepts? So I see most of them. They say that okay, when we talk about object-oriented concepts, they immediately talk about a class object, right? Just a minute, please. Just a minute. Yeah, I'm sorry. So yes, how this objects are related to the class, how class is related to this concepts. Okay. how this how the class is related to object oriented concepts. Let's see. We are talking about objects. I'll also try to help you people to understand how the class is related to this objects. Yes. Okay. Yes. So when we talk about an object, you see, we have different types of objects, right? We got different types of objects, right? So objects are classified further. Further objects are definitely classified. Objects are classified. So for example, you see vehicles is one classification. So every object it belongs to one classification, or you can say one class. Human beings is one classification or one class. Vehicles is another classification. So class, I can say that it represents a group of similar objects. Class actually represents a group of similar objects. Class actually it represents a group of similar objects. Okay. Yes. Now you know you can take any case study. You'll find that okay, you can actually use all these concepts. So let's consider one case study. Okay. Yes. For example, we'll consider this online bank application, a bank application. You see, there are various objects which are involved in this online bank application, you can say. So what are those various objects? You see, we got savings account object. This is one of the important ones. Savings account object, you see, it represents an account in the bank. Now there are several other objects associated with the savings account object, I can say. So can you people identify what are the objects associated to this savings account object? Bill pay, okay. Money transfers, no. I can say first of all we can consider account owner. Account owner or account holder will be there, right? Account holder who owns that account. Yes, you see, there is an association between these two objects. Account holder can be a person who owns that account, right? Who owns the account of the bank. Yes. Yes, bank also. And you see, every account belongs to a particular bank. Yeah, account savings account can be associated to pays a pay, I can say. So now you see, what is the association between? How can we describe the association between account holder and and savings account here? What do you people think? How can you describe the association between savings account object and account holder? You see, I can say that it's very simple association. It's a simple association. Yes, account holder has an account. That's it. You can describe it as a simple association. Account holder has an account. It's a simple association. It is not a composition. Can I call it as a composition? No. Or is there any inheritance relationship here? Is there any parental relationship between these two objects? No. Right? Yes. And you see, savings account and pay also same. It's a simple association, I can say. Savings account and pay is also same. It's a very simple association between these two objects. And what else here? Anything else? I can say address. So address is associated to account holder. Account holder will have an address, right? Account holder will have an address. Account holder will have an address, right? Yeah. And you can say debit card, yes, for an account. A debit card is associated. You see, we can also register the billers to our account. We can register a biller, right? Yes, address is also an object. It represents a house or a home or an office, right? Contact number will be part of address, I can say. Yeah, all such things now. You see, biller and account savings account. Again, biller and savings account are associated, right? So, you see, in this real world, objects are associated. Objects, they collaborate with each other to accomplish a task or a goal. A goal, I can say. Now, all these objects, they collaborate, right? Yes, fine. Now, if we consider in the object's perspective, address has some properties, but what actions are associated to it? So, you see, as I told you people, when I talk about behaviors, I say either behaviors, they represent the actions which are performed by an object or on an object. Now we perform some actions like shipping, you know, the bill, shipping statements. Okay, so that address is needed for you people to make payments, right? So contact bank. How will they contact with you? Through that address. How they will ship your checkbooks or something like that. So how a checkbook is dispatched to you people? If you place a request for checkbook, how it is dispatched? Shipped to address, right? Shipping. Yes. Okay. Hope you got it now. So biller is it can be a third party or any company to whom you would like to make the payments. For example, utility bills, your service providers like internet service providers, mobile service providers. You see, for them you'll make the payments, right? So you can register them as billers, and you can make the payments, utility bills. So biller is a party to whom you would like to make the payments, utility bill payments especially. Yes, it can be insurance bills also. So whatever it is. Okay. And what else? So do you see any other objects involved here? Okay. So I'm not considering this inheritance here. Uh, but you see, can you people give me any example for inheritance in this case? Okay, let me give this example. In a bank, you'll have different types of accounts: checking account, savings account, loan accounts. So for all these types of accounts, you see a current account, we say FT account. You'll have different types of accounts in the bank. So when we talk about these types of accounts, you see, you got something common between these accounts. What is common between all these accounts? Can you people tell me? So there are certain common properties. Okay. Yes, of course, though they are different, slightly different, but they are all accounts, right? They have got some common properties. and behaviors, right? We got some common properties and behaviors. So, for example, you say account number is common for checking account savings. That means every account will have a account number. They'll have balance. All these accounts will have balance. So we perform actions like deposit. That is also common. So that's the reason why here you see they're all similar types of accounts. So what you can do is you can just use this concept of inheritance account and you see you can classify them again further. Accounts can be further classified into checking account, savings account, loan account, FD account. So you can just describe the properties here in the account. They're all common. So they are all the common properties which are inherited by the they're all the common properties which are inherited by the other types of accounts here, right? Yes. Yeah. When I say account, you got something common between them. So when it comes to programming, I'll give you more details about it. Okay, especially for this example. Okay, you can consider this. But we'll discuss more about it later on. Implementation wise, you'll get more details. Okay, so this way, now you say you can think of everything in anything in terms of objects. Okay, yes. So why we have to follow this object oriented concepts? No one has asked this question. So what do people think? What is the advantage of using this object oriented concepts in the programming? We are yet to implement this concept, but first of all, why people are following this approach here? What do people think? Why they use these concepts? Okay, reusability. Okay, so first of all, what was the driving force? How all it started actually? You know, yeah, I do agree what you people said: reusability, extensibility, and all such things. But let me talk about it in very simple terms first of all. What is it? You know, how it all started is this way. We have a problem statement which is actually based on what concepts. You see, generally we develop applications, right? So we develop an application to address any problem statement. So your clients will come to you people with a problem statement, and you should provide a solution through your application to that problem statement. Okay, yes. So that is what happens. Your clients will come to you people with a problem statement. So you should address their problem statement, address the issues related to that through your application. You should provide a solution to that problem statement through the application. So the problem statement which we are talking about, it is also related to this real world, which is also based on object-oriented concepts, which is also based on object-oriented concepts, I can say. That means here you see, so the problem statement itself is in object-oriented concepts. So when the problem statement is in object-oriented concepts, why don't we think about the solution also in terms of object-oriented concepts? That was the main idea. That was the main idea, driving force behind using the object-oriented concepts in the programming. Okay. So because the problem statement is based on object-oriented concepts, so why don't we think about the solution also in terms of object-oriented concepts? Why don't we think about the solution also in terms of object-oriented concepts? So that was the driving force. So which led to using these concepts, and also by using these concepts, people found that there are a lot of advantages. Okay, yes, we got a lot of advantages. So if this is about an introduction to, what is the introduction here, what we have discussed so far? Is it object oriented programming or object oriented concepts? Object oriented concepts. So how these concepts are related to programming? So we use these concepts in the programming. So object oriented programming is all about applying object oriented concepts in the program. Object oriented programming is all about application of object oriented concepts. Okay, yes. So I'll do one thing. I'll give you people a case study. So I want you people to just work on this. Okay, yes. So what is that case study? Let's say you take this example. Um, so might be you might have come across this already, but once again try this. Um, let's say a college. So what is your task now? So you need to identify all the objects. Now let's say, yeah, you need to identify all the objects which are involved in a college. Not only identifying the objects, but you need to also first identify the objects and identify objects and its characteristics and associations between the objects. Okay, and try to identify the features, OOP features, object oriented O features. Okay, yes. So try to use or try to use all the object oriented features which we have discussed. Try to identify those features here in this objects. You should be able to definitely do that. So any questions in this regard? Okay, good. So I wanted to start with implementing this object-oriented concepts, but you know what? Here, um, I want at least a couple of hours to straight away start with the programming. But first of all, I want you people to also just go through the stuff, object-oriented concepts. Okay? Yes. And for your reference purpose, I will suggest you people a site. You please go through it because there's a first thing here. Uh, First class of object-oriented programming. I don't want to be in a hurry. So you'll find Java tutorials from the official site. Don't go here and there for these concepts. So this is the place where you can just you know get the details about this object oriented programming and all. Just a minute. So object oriented programming concepts. Okay, so maybe it's, yeah, object oriented language means it fully supports object oriented concepts, whereas object based language, it supports partially, I can say, fine, in terms of speaking it in simple terms. Yeah, you see, like if you consider JavaScript, if you are familiar with it, if you compare it with Java, does JavaScript provides, or do you see all the object oriented features in JavaScript? No, whereas in Java you will, right? Yes, have you noticed it? So i'll I'm trying to show you people a site from where you can start exploring the things. Okay, first of all, you can do this. Start with this. Yes. Okay. So when you come to the next class, make sure that you go through it, try to understand whatever you can. Okay. I'll leave it to you people. So this is the main page. You can use it as a reference from now on. This is from Java official. Yeah. So I can start now, but I don't want to do that. So I want you people to just go through this first of all. Okay, and then we can start with the programming. First, try to understand the concepts of it. So there, in that example, in that tutorial, you'll find how to apply those concepts also. Yes, that we'll be doing it in our next session. So I'll stop it here, though early, but yes, just this first weekend. But next weekend onwards, you'll have a lengthy session of 3.5 hours. Next weekend, we'll have 3.5 hours. Okay, yeah, that is how it works. First weekend, just an excuse for you people, for me also. So will not work much. But before that, I want you people to just go through that tutorials. Okay, it will help you people to better understand the class. Yeah. Maybe I don't exactly talk about the concepts the way I will be talking about those concepts. The examples, I'll take my own examples. Okay, you can refer to those examples. You can work with those examples also. We'll discuss about other examples in the class. So tomorrow there won't be any class. We have a class again on Monday at same time, 7 p.m. Indian time. That is 7:30 a.m. Central time. Okay. Yes. So again, we have a class on Monday at the rate 7:30 a.m. Central time. So meanwhile, you have enough work to do. Just go through that concepts. Okay, all of you. So study those concepts. What is a class, what is an object, try to understand it. So in the next class we'll discuss about it in detail. Okay, so that's all.